If you've been part of a scientific discussion regarding particle physics, the Higgs boson and the Higgs field were probably mentioned. It is easy to gather that the Higgs boson is some sort of particle. However, what does it do and why does it matter? 50 years ago, scientists weren't sure why some particles had mass and others did not. As a result of this confusion, they thought up the idea for the Higgs boson and have been researching it ever since. Scientists try to probe and collide particles in an effort to prove the existence of the Higgs boson. This was especially difficult because the Higgs boson is invisible to us, and no current sensor can detect one in its natural form. This was especially difficult because the Higgs boson is invisible to us, and no current sensor can pick one out in its natural form. In these last 50 searching years, larger and more powerful particle accelerators such as the LHC have been built to vaporize particles and sift through their debris. In the tunnels at the LHC, protons are sped up to very close to the speed of light and then violently smashed together. The machine's magnets and detectors at the LHC surround and track the debris. These violent smashings are repeated millions upon millions of times every second. Every once in a while, a Higgs boson pops into existence. You would think that this amount of collisions is a bit overkill. The Higgs boson is actually so rare that it only appears once every few billion impacts. But remember, the Higgs boson cannot be sensed directly. No current sensor is capable of doing this. The Higgs boson is unstable and splits into two photons. After trillions of collisions, these pairs of particles released by the rare Higgs boson will build up to something that is noticeable by the detectors at the LHC. With quadrillions of collisions, this buildup becomes even larger. As illustrated in this graph, and this bump in the data grows past uncertainty, the statistics are great enough for it to be considered a discovery, not just a coincidence. This is how the Higgs boson was discovered.
Although you may now begin to slightly understand what the Higgs boson and field are, you may have trouble visualizing it. Picture a field of snow. A skier can glide across the field of snow easily with very little resistance. A person with snowshoes can shuffle through the snow relatively easily, however is slowed by the snow. A person with heavy boots is significantly slowed by the snow. A bird can fly over the snow without being affected by the snow whatsoever. The Higgs field is like this field of snow, but instead of lots of snowflakes, the field is made up of the Higgs boson. Particles that have mass interact with the Higgs field. Electrons possessing very little mass barely interact with the field. Electrons are like the skier. Quarks have a bit more mass and interact more strongly with the field. W and Z bosons have thousands of times more mass, thus causing them to plot through the Higgs field like a person with heavy shoes. Photons and gluons are massless and do not interact with the Higgs field at all. Photons and gluons are like the bird. For more information on the Higgs boson, please click on this link menu to help out. We hope you found this video helpful and/or interesting. Please subscribe for more.